Deals with several different theorems. We're going to talk about inscribed angles and intercepted arcs. You're going to notice there's a lot of triangles in here. So as we go through this, keep in mind of what it's talking about. So an inscribed angle basically is the angle back here in which when it opens up, it makes the outer arc. So when I talk about an inscribed angle, I'm talking about the angle on the end. An arc is the outside of the circle in which it's located. So an intercepted arc is talking about this outside of the circle here. So we know that means that angle B would intercept the arc, which is the measure arc AC. And that means that if I was talking about measure angle C of the arc, that would be called a subtence, which that would be angle B. And if I'm talking about the line also is a subtence of angle B. So if we're talking about the line segment AC, it's still also subtends angle B. All right, so that one kind of talks about the core concepts that you need to know about the angle. So let's talk about Theorem 1010. So the measure of an inscribed angle theorem. Basically, if I have, let me draw another circle here. So if I have a circle, and here is D, and A, and this over here is B, and over here is the center C. Basically, what I'm going to say here is the measure of angle ADB is equal to half of what the arc is. So the measure of AB's arc. So whatever this is, it is half of what the outside arc is. So if let's just say that D, let's say that the angle D measured something like 45 degrees, okay? So if I knew that measure was 45 degrees, that means that measure angle this would be half that. I'm sorry, the reverse. It would be double that. My apologies. So that means that measure AB arc would be 90 because it would be double of whatever that is. All right, and then let's look at another one. This one is the Inscribed Circles theorem. Let's see if I can draw this. It's a little trickier. So we have a line here, and then we're going to zigzag here. Then we have a line over here that zigzags, and it comes across over here. So let's say that angles D and C are the same and A and B are over here. So if two inscribed angles of a circle intercept the same arc, so same arc over here, then the angles are congruent. So that means that measure angle ADB then is congruent to measure angle ACB. Sorry about that. So the two of them are the same. Now, if we look at this from this way, that means that if I was trying to find out the missing degree, then basically you're going to go across from each other. So keep that in mind. It kind of goes back to some of our previous theorems. So let me get a clean sheet of paper, and we're going to talk about inscribed polygons. So the inscribe of a polygon, and let's just do a pentagon, for example. So we have this here, and then here, and then here. Whoops, that's not very straight, but there we go. So let's say we have that. So the circle, the vertices it contain is a circumscribed circle. So a polygon is an inscribed polygon when all its vertices lie on the circle. So in other words, if all of them touch and do not go outside or hover away from it, then this is called a circumscribed circle. And that's just a core concept. It's not really a theorem, but one of the core concepts. So an inscribed right triangle. So this is something that we're going to talk about. So an inscribed right triangle. So if we have this, and then we have this, and we have this. So let's talk about what makes or manifests a right triangle, and how do we know this? Well, the good news is there's some things we can look through. If a right triangle is inscribed in a circle, then the hypotenuse is the diameter of the circle. Conversely, if one side of an inscribed triangle is the diameter of the circle, then the triangle is right. So you don't need to have that little box in the corner is what it's saying. If you have a line that goes from top to bottom, left or right, whatever, and it cuts through the center of the circle, then this is considered a right triangle because that would be your hypotenuse or the diameter. So that means that measure angle ABC is a 90-degree angle. Okay, and that means if and only if AC, the arc AC, the line segment AC is the diameter. Of the circle. All right, so that's what it's talking about here. The last one we need to talk about is Theorem 1013, and that's Inscribed Quadrilateral Theorem. Once again, let me get my circle going here. And this one's a very basic one. So it's not perfect. There's an F, there's my center C, there's my E, there's my D, and there's my G. Now, first thing, all the points of the quadrilateral need to be touching the outside of the circle or on the circle. Now, it says a quadrilateral can be inscribed in a circle if and only if the opposite angles are supplementary. That means that I need to be able to add angles. So angle D plus angle F should equal 180. And angle E plus angle G should also equal 180. If it does not work that way, then this is not going to fall into the inscribed quadrilateral theorem. And in case it'll be something different. But for the purposes of our homework and stuff, it's going to work out. All right, so that's all the theorems. So I'm going to stop this video and we're going to do a part 2, which is actually going to be over the problems 1 through 7 in your note packet.